Hello everyone, welcome to all. Please respond to the polls whether my voice is clearly audible or not. And also, my screen is visible clearly or not. Okay, I hope everything is good to start the class. Okay, let's start. Okay, guys, so today we are going to start our second lecture of Parabola. Okay, so because I was in leave on leave yesterday, that's why I did not took your class. Instead of me, Prabhat sir was taking your class. Okay, so from today we'll continue also, and this is the second lecture of Parabola. Let's start the class. Okay, so so yes, so what is focal chord, right? What is focal chord actually? So focal chord is actually, remember we are only now, for now we are only talking or we are discussing about the parabola y square is equal to 4x. Okay. For now, only we are doing the discussion on the equation of parabola, that is y square is equal to 4x. Is that clear? Yes. So suppose this parabola is y square is equal to 4x and the chord of this parabola passing through the point focus, the chord passing through the point focus, suppose this is s and the coordinate of s is focus, coordinate of s is a0. The chord passing through this parabola in on the sorry, the chord passing through the focus of the parabola is called my focal chord. Okay, so here PQ is my focal chord. Got it? Simple enough. Chalo. Now we'll find the end points of the ends of the focal chord, or we can say end point of the focal chord. Right. So suppose PQ is a chord which is your focal chord, and the parameter of the point P is T1. It is given the parameter of the point P is T1 and the parameter of point Q is T2. Okay, then if these are the end points of the focal chord, then one results we can say, that is T1 into T2 is equal to -1. Got it? T1 into T2 is equal to -1. Right? So how can we prove it? Okay, so let's see. Okay, if T1 is the parameter of the point, T1 is the parameter of the point P, and sorry, and T2 is the parameter of point Q, then what are the parametric coordinate of P? Can you say what is the parametric coordinate of point P having the parameter T1? Can you say that is AT1 square 281. So this is the coordinate of point P. Can you tell me what is the slope of this PQ? Can you tell me what is the slope of this PQ? Yes, this is my focus and the coordinate of the focus is A0. Okay. Okay. So can you tell me what is the slope of PQ? The slope of PQ, how can you find slope of PQ? So here, if you are telling the coordinate of T1 are parametric coordinates are AT1 square 281, then similarly here also we can say the parametric coordinates of point Q are AT2 square 282. Is that or not? Yes. So can you find the slope of PQ? Yes, we can easily find, that is 282 y2 minus y1, that is 282 minus 281 upon 82 square minus 81 square. Okay, from now we can easily find. So since in the numerator you can take common as 2a. If you take 2a as common, then you will be having T2 minus T1 upon if you I'll take common in the denominator as a, then it will be t2 square minus t1 square, right? Now a will be cancelled out, okay? And denominator can be, to the denominator we can write this is t2 minus t1 upon t2 plus t1 into t2 minus t1, a square minus b square. Then the numerator, from the numerator and denominator, t2 minus t1 will be cancelled out. What you are having? You are having 2 upon t1 plus t2. The slope of PQ you are getting, slope of the focal chord. Okay, but what you are getting when the equation of parabola is y square is equal to 4ax, right? Y square is equal to 4ax. Is that clear? Okay, now you got the slope and also you have a point on that line. Now can you tell me what is the equation of this line? Can you find the equation of this line having the point, having the slope 2 upon t1 plus t2 and passing through the point 81 square to 81? The equation of equator of PQ is, what will you be? What will be it? That means y minus y1, y minus y1, right? Y minus y1 is that is 281 is equal to slope is 2 upon t1 plus t2 into x minus 81 square. Yes. Now this line, actually this line is also passing through the point S or focus, and the coordinate of focus is a0. If you'll put in place of x and y, if you'll put a0, what will happen? If you'll put a0 in place of x and y, so it will be a0, that is a minus 281 is equal to 2 into t1 plus t2, and from here 0, x coordinate is a0 na? Yes, this is 0 na? This is 0 and x coordinate is a minus 81 square. By simplifying it, you will get what? See here, 2 will be cancelled out, a will be cancelled out. Yes, so we are having that is minus t1 is equal to 1 minus t1 square upon t1 plus t2. Is that or not? If we'll cross multiply it, we'll get simplify and you will get t1 into t2 is equal to minus 1. You will get t1 t2 is equal to minus 1. You will get proved. So this is the proof. So what is, how can you find the endpoints? Also here we studied, and also we discussed how to find the slope of the focal chord, and also we got a result, input and result, that is t1 into t2 is equal to minus 1. So let's solve one question on it. Okay, so this is a question in your screen. You can solve it easily. And so if 2 minus 8 is at an end of a focal chord, okay, okay, so this is the question. If 2 minus 8 is at an end of the focal chord of the parabola, y square is equal to 32x. Okay, so draw the figure first. So this is my, suppose I'm taking the parabola as, this is my directrix, okay, and this is my parabola. Okay, so this is my parabola. If this is the line, or this is the chord passing through the focus, then this point will be S, whose coordinates is a0. Let's calculate first, then we'll see, solve it. Okay, and it is saying that key one point that is P, whose coordinates is minus 2 minus 8, and another coordinate that is Q, suppose I'm taking, and coordinate of Q is it is saying ki alpha beta. Then you need to find the value of alpha plus beta, correct? Okay, so what is the given equation of parabola? That is y square is equal to 32x. Okay, and can you tell me? Can you simplify it? That is 4 into 8 into x. So here I am getting a is equal to 8. Yes or no? A is equal to 8 I am getting. And suppose if I'll say, if I'll take the parameter of the point P is T. Suppose let's take. Suppose T is the parameter of the point P, suppose I'm taking. Okay. If the point P ka parameter T hai, then what are the parametric coordinate of P will be? That is AT square to AT. So if we'll compare now, both the coordinates, that is 80 square, 280 and 2 minus 8. So by comparing this y coordinate of P, and here we have y coordinate of P as minus 8. So if we'll say 280 is equal to minus 8, then use the value of A, that is 8. So T is equal to minus 1 by 2 I am getting. Okay, T is equal to minus 1 by 2 I am getting. Okay, clear? Chalo. So if the parameter of the point P is point P is T, and T is equal to minus 1 by 2 I am getting, then what will be the parameter of point Q? Can you tell me what will be the parameter of point Q? Yes, we know. If in the previous result you have seen that. Oh, sorry. In the previous results, we already studied that T1, if T1 is the parameter of point P and T2 is the parameter of point Q, then T1 into T2 is equal to minus 1. So you have T is equal to minus 1 by 2, right? If T is equal to minus 1 by 2, then Q, if I'll check T1 is the parameter of point Q, then T into T1 will be minus 1. So we know value of T is minus 1 by 2. So minus 1 by 2 into T1 is equal to minus 1. Then T1 will be 2. So parameter of the point Q is 2. So T1 becomes 2. Okay. So parameter of point Q is 2. Okay. So here I'm writing parameter of point Q is 2, right? If it is 2, then what will be the coordinate of Q? Yes, we know it is given that coordinate of point Q is alpha beta. So by using the parameter of Q, we can now find, that is the coordinate will be 8t1 square. Coordinate of Q will be A is, what is the value of A? 8. 8 into T1 square, that is 2 square, 2 into 8 into T1, that is 2. Okay, so it becomes 32. So coordinate of Q we are getting, that is 32. Now tell me, if alpha beta you are getting 32, then alpha plus beta will be, hence alpha plus beta will be 64. So 64 is the correct answer. Is that clear to everyone, guys? Is it clear to everyone? 64 is the correct answer. Clear, guys? Shall we move? Yes. JNB Jasami, is it clear to everyone, guys? If you have any doubt, you can ask. Just here we use the previous result, right? Tick. Now, sorry. Now, the length of focal chord in terms of parameter. If parameter is given, then how can you find the length of the focal chord? Suppose here parameter for the point P, it is suppose T1, then Q, for Q it is T2, right? So length of PQ will be What is the formula? Remember, the formula is A into sorry, SN11. So if you take, it is the parameter for P is T, then Q will be, already we know na, that is 1 by T. Okay, so length of, if the parameter of P is T and Q is 1 by minus 1 by T, you know it, then the length of PQ will be, that is A into T plus 1 by T whole square. Remember, this is the formula to find the focal length, or sorry, we can say that is length of the focal chord when the parameter is given for the PQ. Okay, if you have the parameter for the point P and also you have the parameter for point Q, then you can use this formula to find the length of PQ. Okay, that is T plus A into T plus 1 by T whole square. You can easily also derive it, right? You can easily derive it also. So no need to do the derivation. Chalo, remember this one, length of focal chord in terms of parameter. If parameters are given, then you can easily find, that is A into T plus 1 by T whole square. Okay. Chalo. Next thing is, in terms of angle also, we can find if the focal chord makes an angle alpha with positive x-axis. Okay, here we are discussing about the parabola y square is equal to 4ax only. In all the cases, we use these equations now, for now. Next, we will discuss about the general formula or everything. Okay, general equation. So y square is equal to 4ax. Okay, so in terms of angle, when you have that angle which is made by PQ with the positive x-axis, suppose it is alpha, then the length of PQ also you can find, that is 4a cos x square alpha. Remember, 4a cos x square alpha. This is the formula to find the length of the focal chord when the angle is given. That angle is made by the focal chord with positive x-axis. Clear is that? Yes. Remember this formula. Two formula you need to remember. When the parameters are given, you can use this formula to find the length of the focal chord, that is A into T plus 1 by T whole square. Okay, and another one is when the angle is given, you can find also the length of the focal chord, that is 4a cos x square alpha. Is that clear to all? Okay, let's move. Now we'll discuss length of the focal chord. Okay. Also, there is a note. Semi-latus rectum of the parabola y square is equal to 4x is the harmonic mean between the segment of any local chord. That is, if you have the semi-latus rectum of the parabola, and it is saying that the harmonic mean between the segments of any focal chord of the parabola. That is, suppose this length is L1, PS length is L1, and QS length is L2. Okay, then it is saying that harmonic mean of L1, L2 will be lattice rectum, length of the lattice rectum upon 2. That is harmonic, but how can you find harmonic mean of two numbers? That is 2 L1 L2 upon L1 plus L2, right? Which is equal to 4a. Length of the lattice rectum is 4a. So 4a upon 2, that is 2a. Okay, so this is the formula. Okay, there is a relation between A and L, the segment. Okay, between the segment of any focal chord. Okay, it's a result. Okay, so let's move. Now we'll discuss position of point with respect to parabola. Already we have discussed all these things previously. Also for the straight line also we have discussed, and for the circle also we have discussed. Yes or no? Sure, let's see. So how can you find, if you have a point, how can you find, or how can you check whether that point is lying on the circle, on the parabola, or that point is lying inside the parabola, or the point is lying outside the parabola. It's very simple. The same procedure you need to follow. Okay. So here, if the parabola, equation of parabola is y square is equal to 4ax, then in case of circle, what we did, just we have to put that point, put that coordinate of points, okay, in the given left hand side of the equation. Then if you are getting s1 is greater than 0, it is lying outside the circle. If it is less than 0, then it is lying inside the parabola. If it will be equal to 0, then the point is lying on the parabola. Is that clear to one? Okay. So here we have y square is equal to 4x. So my s becomes y square minus 4x. Yes, it is becomes s. S is y square minus 4x. Suppose what I am taking, this is the point whose coordinates are x1, y1. Okay, so it is lying inside the parabola. When we can say the point is lying on the parabola, this is the point. If this point is q and the coordinate of this point is x2, y2, suppose I'm taking, then if you are getting s1 after putting this point, if you are getting s1 is equal to 0, then you can say the point is lying on the parabola. Suppose the point is r whose coordinates are x3, y3. In this case, we can say s1 is greater than 0, or we can say the point is lying outside to the parabola. So what is s1? So s1 is actually y1 square minus 4ax1. If it is lying inside the circle, then s1 must be less than 0 for the case inside. Okay, if s1 you are getting, that is y1 square minus 4ax1 is equal to 0, then we can say it is lying on the parabola. Okay, and if you are getting s1 is equal to y1 square minus 4ax1 is greater than 0, then you can say the point is lying outside the parabola. Clear, everyone? So these are the conditions to determine or to check the position of a point with respect to the parabola. All of you clear about it? What is S1? What is S? Yes, S is the left hand side of this equation. Okay, and S1, what is S1? When you are putting the given point in the given equation. Clear, guys? Yes. So suppose I will change the equation to x square is equal to 2ay. So here my s becomes x square minus 4ay. Yes or no? So p, coordinate of p is suppose x1, y1. So in this case, what will be your s1? So s1 will be x1 square minus 4a y1 y1, right? If it is greater than 0, then we can say outside the circle. If it is less than 0, then inside circle. Sorry, I'm sorry. Actually, I used the word circle. No, parabola. If it is equal to 0, then we can say on the circle. On the parabola. Clear, everyone? Yes. Sure. If it is clear, now we'll discuss the position of a line with respect to a circle. Parabola. Position of a line with respect to parabola. Okay. Sure. So suppose your equation is given as parabola. Equation of parabola is given that y square is equal to 4ax, and the equation of line is given that y is equal to mx plus. Right? So when we can say the line is intersecting to the parabola, it is the case of intersecting this line. It is the case of intersecting the parabola. It is intersecting. Here it becomes a tangent. Here the case that is non-intersecting. Is that clear? One line is intersecting, or second choice or second case is when the line touches the parabola, then we can say that line is a tangent to the parabola. And when there is no point of contact, or we can say that line is non-intersecting to the given parabola. So what are the conditions? How can you check whether that point is intersecting or non-intersecting, or it is a tangent? So just solve these two equations. We know we have y is equal to mx plus c. So put the value of y is equal to mx plus c in this place, in place of y here. So we have y square is equal to 4x, and if you'll put in place of y, if you'll put mx plus c whole square, then 4ax. So by solving this equation, you will get a quadratic equation, right? So by solving these two equations, you will get these equations, you will get a quadratic equations. So we know in quadratic equations, when we have equation, we have a quadratic equations when the discriminant is greater than 0. When the discriminant is greater than 0, that means we have two roots, real and distinct rules. Okay, when d is equal to 0, then we know we have only one root, or we can say repeated roots, or it touches the parabola. Here we in this case we can say the line is touching to the parabola. Yes. And the third case is if d becomes less than 0, there in quadratic equations we know we are getting the imaginary roots, right? So but in this case, when we are solving both the equations, where when you will get d is less than 0, that means there is no point of contact between parabola and the line, or we can say that line is non-intersecting case. I hope this is clear to everyone. So the cases are, what are the case? The case are, first one is d is greater than 0. When you will simplify these equations, you will get a quadratic equation. Okay, and when you are getting a quadratic equations, if I will say d is greater than 0, that means d is greater than 0. That means this is the case when the line intersecting to the parabola, because we have solved both the equations. Now we have solved the equation of parabola and the line. That means if we are getting two roots, if we are getting the discriminant is greater than 0, that means we are getting two roots. If you are getting two roots, that means line intersecting to the given parabola. Is that or not? So d is greater than 0. That d is greater than 0 means the line intersecting to the parabola. Okay, this is the case of intersecting. Okay, if d is equal to 0, then it becomes, line becomes a tangent. Okay, if you are getting d is less than 0, this is the case of non-intersecting. Okay, non-intersecting. Okay, so these are the three cases. Similarly, if you find d, d means from here, if you try to find d, so d will be actually mx plus c. You will get d as mx plus c. Sorry, a minus mc. Is that a minus mc? You will get d as a minus mc, and if a minus mc is greater than 0, this is the case of intersecting. And if you are getting a minus mc directly, if you can remember a minus mc is equal to 0, then you can say that line is a tangent to the given parabola. And if you are getting a minus mc is less than 0, then the line does not intersect to the given parabola. Clear? Is that clear to everyone, guys? So these are the cases to check whether a line intersecting or non-intersecting or tangent. So what is the conditions of tangents you are getting? So actually conditions of tangency. When a line, in which condition the line becomes a tangent to the parabola. If you have the equation as y square is equal to 4x and the equation of line as y is equal to mx plus c, then the conditions of tangency will be a minus mc is equal to 0. A minus mc is equal to 0, that is a is equal to mc. So c becomes a by m. So this is my conditions of tangents. C is when c becomes a by m, when c becomes a by m, then you can say this is the line is a tangent to the parabola. Clear? The line becomes a tangent to the parabola. Clear, everyone? So this is my conditions of tangency. Remember, everyone, this is important also. Conditions of tangency is when the line touches the parabola and C becomes A by M. Okay, clear? Shall I move to the next thing? Sure, let's move. Now, you have a note for you. That is, if you do a very small lever, then you can also find the length of the chord of slope m. Suppose if you are having a chord, I'm not talking about the focal chord, just a normal general chord you are having, then if that chord is having the slope m, okay, length of the chord intercepted by the parabola y square is equal to 4x on the line y is equal to mx plus c is actually length of the chord will be, if you can remember, it will be easier. Length of chord will be 4 by m square. Remember, 4 by m square into root of a into 1 plus m square into a minus mc. If you can remember, it will be easier. I hope you will try to remember this one. If you have a line y is equal to mx plus c, and which is also a chord to the parabola, if you are asking to find the length of that chord, then easily you can find that is 4 upon m square into on root of a into 1 plus m square into a minus mc. Clear? Sure. Okay. Now we'll find how we can find the equation of tangent at a point. Suppose in this case, here you have a point P whose coordinates is x1, y1. Okay, and you have the equation as y square is equal to, equation of parabola is as y square is equal to 4ax. Clear? 4ax, y square is equal to 4x. So how can you find the equation of tangent? Simple thing. We already discussed these things in case of circle also. So at a point, how can you find the equation of tangent? This is very simple. Just what is S here? S is y square minus 4ax. So what is T? T will be, in place of y square, we need to substitute y1. And in place of x, we need to substitute x plus x1 by 2. This is the shortcut already I told you, na? Yes or no? So T becomes y1 minus 2 into a into x plus x1. Okay. So here now we can say T is equal to 0 is the equation of tangent, or in place of T we can substitute this is the equation of tangent at a point. Okay? Or we can write in place of y, if we substitute y1 minus 2a into x plus x1 is equal to 0. This is also the equation of tangent. This is the point form of equation of tangent, right? Clear, everyone? So what are the substitutions in each case of conic section? Okay, what we are doing for circle will do for parabola also, ellipse, and also for hyperbola. Clear? Chalo. So what are the transformations we used to get the equation of tangent, that is in place of x square, in all cases where you are getting x square, just substitute as x1. If you are having a y square, then in place of y square substitute y1, and if you are having x, then substitute x plus x1 by 2, and if you are having y, then in place of y just substitute y plus y1 by 2, right? Then t is equal to 0 will be your equation of tangent. Is that clear to everyone? Clear? Bolo, is that clear to all? Hello everyone, clear? Sure, let's move. Now, what is the parametric form of the equation of tangent? So this is also simple. That is the thing only you need to do. If you have a point P and whose coordinates is 80 square 280. Okay, so when in this case already we studied when you are having the point as x1 y1, then you are getting t is equal to 0 is the equation of tangent. So in place of x1 y1, here we are having 80 square parametric coordinates, we are having 80 square 280. Then the equation will be t is equal to y1 is equal to 2a x plus x1, that is y1 minus 2a into x plus x1. So in place of x1 y1, what we will substitute? 80 square 280. Yes, so y into 280 minus 2a into x plus 80 square. Okay, 80 square. So now this is equal to 0 is the parametric equation of the tangent at a point when you are having the parametric coordinate of a point. Okay, so equation will be, after simplification you will get ty is equal to x plus 80 square. So this is the parametric form of equation of tangent. Clear guys, everyone? Clear? Okay, let's move to the last form, that is slope form. Slope form is actually the conditions of tangency when you are having line is y is equal to mx plus c, suppose, then the conditions of when this line will be a tangent to this equation parabola, then what is the condition? That is c is equal to a by m. So this is the equation conditions of tangency. Yes or no? So if you are having the line as y is equal to mx plus c, then the equation of tangent will be equation of tangent is equal to, what will happen? That is y is equal to mx plus c. In place of c, just substitute a by m. So this is my slope form of a tangent. Okay, slope form of a tangent. Okay guys. Okay, so the last thing I need to discuss with you, that is the relation between slope and parameter for the parabola. Okay, so that is remember, we'll discuss these things in the next class. It needs a little bit derivations. Without derivations you can't actually understand. So let's start for the next class from here only, and we'll try to complete this parabola in this week only. Okay guys, so thank you, thanks for your time, thanks for your patience, thank you all. Chalo, bye bye, take care everyone. The next class will start from here only. Thank you all, you can leave now.